Welcome to the Metabolic Maestro podcast, where we help you orchestrate your metabolism one note at a time. I'm Kathleen, a synthesized voice Bob has chosen to narrate his podcast. This is episode 6, Vitamin C, Glutathione and Redox Recycling. This is the 6th episode of the Metabolic Orchestra series. In the last episode, we've talked about electricity, ATP, mitochondria, minerals, and calming the nervous system by reducing neural excitability. Today we will learn about maintenance, because energy production creates wear, and without repair, efficiency collapses. Vitamin C sits at the center of metabolic repair, not as a simple antioxidant, but as a recycler. Part 1. Why antioxidants are misunderstood. Oxidation is not the enemy, it's inevitable. Every time electrons move, some escape. Those escaped electrons create reactive oxygen species. This is the cost of life. The goal is not elimination, the goal is control. Part 2. Vitamin C is an electron donor. Vitamin C does not block oxidation entirely. Instead, it accepts and donates electrons and resets systems. It keeps redox reactions reversible. This is its power. Vitamin C acts primarily as an electron donor, a reducing agent. It donates electrons to neutralize reactive oxygen species ROS and other oxidants, becoming oxidized itself in the process. But vitamin C doesn't just block damage once and disappear. Instead, it gives away electrons to calm down harmful oxygen molecules, those troublemakers that cause oxidative stress. In doing so, vitamin C itself gets used up temporarily. It changes into a spent form called dehydroascorbic acid or DHA. Whole part? Body can recycle DHA right back into fresh, active vitamin C using help from other systems like glutathione. This means one molecule of vitamin C can keep protecting you over and over again, instead of being a one-time hero. It stays in the game, passing electrons around to keep everything running smoothly and allowing it to be regenerated and used multiple times rather than being a one-and-done scavenger. By donating electrons, vitamin C resets or regenerates other antioxidants, most notably vitamin E. Oxidized vitamin E is reduced back to its active form by ascorbate, extending the antioxidant network. Vitamin C and glutathione pass the workload back and forth, supporting each other. Glutathione directly recycles vitamin C by reducing DHA back to active ascorbate, but vitamin C indirectly returns the favor by handling large amounts of ROS upfront, protecting glutathione which would otherwise be overwhelmed. Together they create a reusable defense system. Vitamin C also helps maintain metal ions such as iron and copper in reduced states for enzymatic functions. Part 3. Where vitamin C lives. Vitamin C concentrates in mitochondria, adrenal glands, brain tissue, and immune cells. These are high-stress zones and places where electrons move fast. Part 4. Vitamin C and electron flow. Vitamin C can donate electrons without becoming unstable. This allows it to neutralize radicals, prevent chain reactions, and protect membranes. But it does not work alone. Part 5. Glutathione, the central cleaner. Glutathione is the cell's primary detox molecule. It exists in two states, reduced and oxidized. Reduced is the active form and oxidized is the inactive form. To restore its active form, the enzyme glutathione reductase uses electrons from NADPH, a molecule that carries a phosphate group. Vitamin C works as a complementary antioxidant alongside this system, helping defend against oxidative stress. This recycling is critical. Without it, the cell's detoxification capacity would stall and oxidative damage would accumulate. Part 6. The glutathione cycle. To maintain glutathione, the body needs glycine, cysteine, and glutamate, the three amino acids that make up glutathione, plus magnesium and NADPH, nicotinamide adenine dinucleotide phosphate, reduced form. This comes from the niacin, vitamin B3 you eat. Vitamin C supports this cycle as a complementary antioxidant. Without adequate NADPH, glutathione would become trapped in its spent oxidized form and cannot be recycled back to active form. Part 7. Vitamin C and mitochondria. Inside mitochondria, vitamin C reduces electron leakage, protects iron-containing enzymes, and stabilizes membranes. This lowers the cost of ATP production, and energy becomes cleaner. Part 8. Vitamin C and iron. A delicate balance. Vitamin C increases iron absorption. This is useful, but inside cells, vitamin C also keeps iron in its proper state, preventing iron from generating uncontrolled radicals. Vitamin C does not increase damage. It prevents mismanagement. Part 9. Vitamin C and carnitine. Vitamin C is required to synthesize carnitine. Carnitine transports fatty acids into mitochondria. Without adequate vitamin C, carnitine synthesis drops. Since carnitine shuttles fatty acids into mitochondria, its shortage causes lipids to pile up in the cytosol instead of being oxidized for energy. This forces cells to rely more heavily on glucose, raising the respiratory exchange ratio and reducing metabolic flexibility. Meanwhile, the accumulating fatty acids don't just sit idle. Some convert back into triglycerides for storage, while others activate stress signals that impair insulin signaling. The result is a paradox: abundant fuel, but inefficient energy production and fat being stored. This is a hidden link between vitamin C and metabolic flexibility. Part 10. Vitamin C and collagen. Collagen requires vitamin C. Healthy collagen means stable blood vessels, efficient oxygen delivery, resilient connective tissue. Structural weakness creates inflammatory signaling, and vitamin C reduces that noise. Part 11. Vitamin C and stress hormones. The adrenal glands are small, triangle-shaped endocrine glands located on top of each kidney. They store high levels of vitamin C and play a crucial role in your body's response to stress, regulating metabolism, blood pressure, immune function, and more by producing essential hormones. The cortisol production consumes it and chronic stress strains it. This creates a feedback loop. Low vitamin C impairs adrenal hormone production and antioxidant defenses, leading to heightened stress responses. Stress lowers vitamin C, and low vitamin C increases stress sensitivity. Part 12. Why deficiency feels subtle. Vitamin C deficiency does not only cause scurvy. More often it causes slow recovery, low resilience, easy fatigue, and poor stress tolerance. Energy production continues, but cleanup lags. Part 13. Vitamin C is water-soluble by design. Vitamin C turns over rapidly in plasma, with a half-life of 30 minutes to 2 hours. The kidneys conserve it below a threshold but excrete excess quickly, requiring regular intake, especially during stress when needs increase. However, tissue stores persist 10 to 20 days, preventing rapid deficiency. This dual system provides fast antioxidant response while buffering reserves. This is adaptability, not inefficiency. Part 14. Vitamin C and the energy network. Vitamin C supports mitochondria, glutathione, iron control, fat oxidation, and hormonal balance. It does not create energy, it preserves capacity. In closing, energy systems wear down. Vitamin C keeps them reversible. It recycles damage before it becomes dysfunction. In the next episode, we'll shift to the kidneys, electrolytes, citrate, and acid-base balance, and why energy depends on waste management. Until then, health is not just production, it is maintenance.